Hi, my name is Val Huber. Welcome to this demonstration of automated business logic with Grails. What we'll show you is an order entry application focusing on the business logic to compute the balance by rolling up the line items through the order into the customer and checking the customer's credit limit. We're going to show it in a way that results in shared business logic that is not local to a controller, so it can be shared across controllers and to message-based transactions. So here's our Grails application. You probably recognize this as the standard look and feel. This is about customers, orders, and items. So let's begin by looking at some customers. And we note that the balance is 85 for alpha. We'll look at the purchase orders under alpha and open up number 6. Maybe look at the first line item, edit that, and change this quantity to a 1. To an update, notice down here there's lots of logging going on. When we come back, we notice that the balance has changed. Similarly, we go back down to this same order. And try to buy lots and lots of these. And we get the expected constraint because we have business logic that makes sure that the roll-up of the order item totals through the purchase order into the balance does not exceed that customer's credit limit. So now let's have a look at how we built that application in SpringSource Tool Suite. Again, as we said earlier, defining it such that it's not local to a controller, but shared. You build your Grails application in the usual manner. You build your domain objects, let Grails generate your controllers, and what's different is under the Groovy, Source Groovy folder here, we see that we've introduced business logic components, these are Groovy classes, that correspond to our domain objects. These are where you specify your logic, like this. So here's the customer logic object. These annotations represent rules that are to be executed by the rule engine. For what transaction? Let's take a look at the purchase order requirement that says check the credit limit when we change something in the purchase order. So if you were to discuss this with your business user to make that a more formal definition, you might write down requirements like this. You might say that the constraint, there might be a constraint where the balance must be less than the credit limit. The way you identify that in business logic is you provide a logic method, you provide the annotation constraint, and here you code the Groovy if-then-else logic that if this fails, you signal this. Notice you can use if-then-else logic, you can refer to multiple attributes, you can use all the stuff that Groovy is familiar with, set breakpoints, and so forth. The second piece of logic in this definition of this requirement might be the definition of the term balance. The stepwise definition says that when we introduce a new term, we define what that means, and your business user may tell you that that's the sum of the unpaid order totals. Well, in fact, that's exactly this rule here, entered almost exactly it was on, let's say, the cocktail napkin. This is a sum rule, that's a derivation. And what this is saying is from the customer object, get the related purchase orders, that's the role, the amount total attribute, add them up, only for those purchase order where the paid is false. It's worth noting that this particular piece of logic is not pertinent to adding an order, modifying an order. It's for any transaction that touches a purchase order. So whether it's being paid or moved from customer 1, all the use cases you might imagine from that user interface we saw are automatically automated by this piece of logic. Next thing we might say is, okay, that's fine. What is the orders total? So the order total, the business user might say, well, that's the sum of the line item amounts. So for that, we introduce our second logic object called purchase order, and we define a similar rule for line items.amount. The next rule says, well, what is amount total? Beg pardon, line items amount. That's the price times the quantity. That's this logic right here under line item. As you can see, if the logic is very simple, you can define the entire logic just in the annotation. If it's more involved, you can break into groovy.java as we did up here. And finally, the system obtains the product price with this copy rule to finish our transaction. So that's literally all of the logic it took to build that entire transaction. So let's have a look at the architecture by which that happens. You define, for example, in STS, your Groovy application in the usual manner. You define your domain definitions and in your wizard. You run the wizards to create your views and controllers and add the rules as we showed. How does that work at runtime? Well, the Grails web layer makes calls into GORM. That's the Object Relational Manager of Groovy, which is a simplification layer over Hibernate. What happens next is that the business logic engine plugs into Hibernate events, monitoring every single update. When it gets an object, it looks up the rules and enforces the logic specifications you gave for all changes. As we said earlier, these rules are sort of declaratively encapsulated so that they manage every single transaction that touches that data. Automated business logic provides significant benefits for your organization. First is agility. The 5 rules we saw in the demonstration replaced fully 500 lines of code. We know this because we built them and we provided copies of them on the website so you could have a look at them. That's 50% or more of your development effort for database-oriented web apps. In addition, while this was a very simple application, automated business logic is extensible. You can write rules in Java or Groovy, providing if-else logic, and utilize your IDE's editor, debugger, and logging. You can also use Java or Groovy to provide new rule types, and we've used these, as also shown on our website, to automate high-end complexity transactions such as a bill of materials explosion, or the application of a payment to a set of outstanding orders. The agility benefit of return on investment extends to total cost of ownership. First, the transparency of the rules, they can be spun out for reports, enables your business users to connect with the actual implementation and engage with IT to reduce requirements risk. Rules are automatically reused across use cases, so this guarantees compliance and safeguards your data. Rules are automatically ordered. This helps automate maintenance, since the bulk of maintenance effort is really the archaeology of understanding the ordering of the existing logic so as to make changes that are correct. With automatic ordering, all you do is change the rules and the system reorders the logic based on the new dependencies. These are discovered at execution time, not by code generation, by a combination of introspection and bytecode analysis. Finally, the system provides extensive enterprise optimizations. We mentioned earlier how the sum rule is actually an adjustment. It's not a SQL sum. There's extensive pruning based on the analysis of the incoming transaction, and you can read more about these on the website. So that's a quick look at automated business logic. You can read more about it on the website and download a copy. We'd love to hear from you. Thanks very much for your time. Bye.